Good evening, sir.
Good evening. Good evening. All good?
Good evening, sir.
Good evening. Can you see what is written on the screen?
Yes, sir.
Very good. Okay, everybody came.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening. So we are 4 or 5 people.
The
Sir,
four
four,
people.
sir. Four.
Okay, everybody came.
Yes, sir.
Yes, sir. Yes, sir.
So there are 3 aims for today. Okay. First is to know how to know that a rational number is terminating rational number or non-terminating rational number. Second, if at all it is non-terminating, how do we represent it? Okay. Third, which is completely opposite, given a decimal representation of any number, how to extract the rational number from it. Okay. These 3 things we will be seeing too. Any
Yes, sir.
questions before we start?
No, sir.
No, sir.
Okay. So let's see the first.
Will we have to write anything today?
How do you usually do?
Ma'am teaches us a topic and then she gives us a few sums on that topic and we write it. Yes.
Yeah, that anyway we will be doing. As and when you are comfortable, you can do that.
So first you'll finish
Okay,
the
sir.
topic, then you'll give us few sums.
Yes. Okay. So let's see part 1.
Yes, sir.
How to know a rational number is terminating or not. For example, I give you 2 rational numbers 2 by 3 and 2 by 5. Can you tell quickly who is terminating and who is not terminating?
2 by
So
3 is
2 by
not
3
2
is
terminating.
by
not
3
terminating.
is non-terminating, 2 by 5
5 is
It's terminating.
terminating.
Very good, very good. You could tell because you know how to divide
yes.
all
Yes,
numbers.
sir.
But if I give you big numerators and denominators, it will take some time.
Yes.
Yes, sir.
So what is the strategy to quickly tell somebody is terminating or not? The plan is, when you have any rational number, try to write the prime factorization of Q.
Yes.
If it is coming as product of 2 power m into 5 power n, only and only,
So what is M and N?
it is the powers of 2 and powers of 5. For example, I could write 2 by 5 as 2 divided by 2 power 0 into 5 power 1. Yes or no?
Yes,
Yes, sir.
sir.
Yes.
Sir,
Similarly,
but 2 power 0 is
1.
like,
See,
yeah,
that's
1.
1
into
into
5.
5.
5, 1 into 5.
5. Now
Yeah,
for
but
for
it makes
example,
no difference, right, sir?
Yeah, that's why we are making it easy. Making
Yeah,
that
so it's
easy.
irrational. Sorry,
So
it's
let's say
non-terminating.
we started with 18 by 40. We don't know it is terminating or not. So 18 divided by 40. How can I write as 40? As
2 to the
So
power of
9
0
divided by, okay, sir. I thought it was simplified.
So why 2 to the power of 3 now?
8 into 5.
It should always be 2 into 5, 2 to the power into 5 to the power.
Yes, yes. So plan is
So,
whenever
like where did 8 come from?
2 power
it is
3.
the factorization of 40.
Okay. So to the so the power of 5 should always be 1.
No, not like that.
No, it can be anything. See, 2 to the power of m. M can be anything. You can like
So if I can write 2 raised to 2 into 5 raised to 2. Oh, no, I can't write that.
Another number is
Okay, I get it.
213 divided by 125. How to write it? 213 divided by
2 raised to
So
0 into 5 raised to 5 at 3. Oh.
yes.
yes,
so
sir.
what
Yes,
if it's 20 divided by 40?
Again, I don't
40 to
reduce it. I just want to see the factorization of denominator.
20 by 2 to the power of
2 to
3
the power of
into
3
5
into 5 to the power
to
of
the
1.
power of 1.
Yeah, so it's not non-terminating.
So plan is a number will be terminating only and only when the prime factorization of the denominator is of this form. This
So
is
for
the
2 by 3,
So,
I can't do this.
So if I don't, if like let's say the denominator does not multiply with 2 to the power of m and 5 to the power of n, that is a terminating number.
that's a non-term. So this is terminating format.
So for 2 by 3, I can't do this.
Yeah, 2 by 3 because factorization of 2 by 3 is what? 3 power 1.
That's it.
3 power 1 is not of the form of 2 power m into 5 power m.
Yes.
Since the factorization of denominator is not of this form, this is a non-terminating number.
So I can write 2 power 1 into 5 power 0. Right? That's
That's
3. Right?
basically 1 and 2 power 1.
2 power 2.
How is
2
2
into
into 1
1.
2 divide
2 into 1 is not equal to 3.
2 power 1
Okay.
is 2 into 5 power 0 will be, which will be 1. So 2 plus 1 will become 3.
2 into
Plus,
that.
Oh, it's
Where did
into.
plus come?
Oh, it's into. Sorry, sir. I thought it
Yes.
was plus. Sorry.
So it's like this. Let's say I bring all the rational numbers in this bag. Okay. This is all the rational numbers. There are two types of rational numbers, terminating and non-terminating.
non-terminating.
The trick to identify terminating number is that its rational form will look like p divided by 2 power
2
m
plus
times
into 5 power n.
into 5 power m. And non-terminating does not look like this.
Yeah, that's
Yes, sir.
it.
Now can any one of you tell why only 2 and 5 are there for it to be a terminating number?
Yes, sir. That's what I asked you. Like when I was asking, why is it only 2 and 5?
Why is it only 2 and 5? Do you have any answer? So let's see. Why? Let's take a number 170.
Sir. Because every even number is with 2, and like if it's 5, it goes to every 10s and 5s.
Even 2 can
So
go down.
yeah, like that's why.
So
So
see,
like
an example will be better. Let's say I have a number 179 divided by 8 into 8 into 25, which comes around 200. Okay,
Yes, sir.
so let's see a calculation. Is it okay if I write this as 2 cube into 5 square into 5 and to balance into 5? Is it okay?
Yes, sir.
Yes, sir.
Yes,
Right.
sir.
Very good. Now what comes in the numerator?
Um,
2
two
cube into 5 cube.
895.
2 cube into 8 cube. Sorry, 5
So,
cube.
numerator.
Oh,
Eight
one cent.
895.
895. And what comes here? 2 cube into 5 cube.
5 cube.
So what about the 5, sir? Into
That's a 5 square into
Yeah.
5 becomes 5 cube.
oh, okay. I didn't see you change it.
Is it okay if I can write it as 2 into 5 power whole cube?
Yes, sir.
Yeah.
Sir,
Is
it's a
it,
4. Oh no, wait, that's not.
is
Yes,
it
sir.
okay if I can
Yes, sir.
write it as 10 power 3?
So I have a doubt.
Yes,
Yes,
How
sir.
did you get 2 to the power of 3 into 5 to the power of 2 into 5? Like, where did the 5 come
Yes.
from?
So I
You're
have,
factorizing. I mean, you're making both of them equal like that.
Yeah.
I have a plan in mind. The plan is I want to see denominators as
A single number
multiples
cube.
of 10. 10 should come somehow. Okay.
So
See
if
the
I do
calculation.
3, it will come like 15. So it won't come 10.
So I wanted 10 powers of 3. Okay. See, 2 cube into 5 square. I multiplied 1 5 so as I can write 2 cube into 5 cube, which will later give me 10 cube.
So we have to multiply
Yes.
the denominator with a number so that both the
And numerator.
both
No, like it
and the
just.
numerator. So
So,
both
so
the
your
denominator.
Denominator will become equal. Both the power of the denominator.
Yeah.
will
So
be
I
equal.
So
want
you're
to
basically
equalize.
multiplying the denominator and numerator with 5 just so that the in the denominator will become 10 cube, which makes it simpler,
Yeah, we
like
say
easier to do it.
equalizing powers of 2 and 5.
Yes.
Yes. 2 had power 3. 5 had power 2. I want to equalize it. Since 2 is short, I give it one more power by multiplying by 5. But I have to neutralize also. So multiplied the numerator, which gave me 2 cube into 5 cube, which later became 10 cube. And I can now write this as 895 divided by 1000,
Yes.
which is 0.895.
9.5.
So if
Yes.
if it's 2 cube into 5 power 1, I have to multiply both the numerator and denominator with 5 square.
Yes, very good.
So it is non-terminating.
Equalizing.
This is a terminating number.
Sorry.
Oh, yes.
Okay,
The terminating number cause it ends.
because it ended. Yes. Okay. Let's
Even that bunch of examples which you gave on the previous slide was terminating, right?
Yes.
this was
2 by
these
5.
all 2 by 5 it was terminating. 18 by 40 is terminating. Can you tell in 213 by 125?
So you have to multiply it with 2 cube and then multiply the numerator also with 2.
Yes.
So it'll be 10
So can you
cube at
just
the
stay in
bottom.
this slide for once?
Which one?
This slide.
Take a screenshot.
Okay. Now let's see whether you can do this problem and identify whether this number is terminating or not. What about this?
Uh,
Is it a terminating number or non-terminating?
Sir, it's terminating, sir.
Let's see.
It's 2 cube into
The 257 by 640 is 640 can be written as 8 into 64 into 10.
Yes, it can
yes,
be
sir.
written as
64 into 10.
so
Ooh,
8 8s are 64, so I just did it right.
so we can also do it like 2 to the power of 3, which is 8, into 5 to the power of 8 tens are
no,
80.
it won't work.
128 into 5.
Okay, yeah.
Is it fine?
Sorry,
Yes, sir.
yes.
Now, since the
It's not.
denominator's representation, the denominator's prime factorization is of the form of 2 power m into 5 power m. This is a terminating.
Terminating.
So this is terminating.
Sir, like how do you find 640 like divide it into faster? So like getting the power of it.
Yeah, like
Uh,
that's quite tough.
Quick thinking in exams.
Yeah, it's because when you do good number of questions, by practice you will learn powers of 2, powers of 3, powers of 4 and 5. So for a sample, powers of 2 go like this: 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. Like
Yes.
4096, 8000, 192.
so
Yeah,
it becomes a habit.
16,384, 32, so like that.
Yeah. So what about this number?
Which, sir?
453 divided by 192. Is it terminating or non-terminating?
Uh, Sir, can I also use
Sir, it is,
decimals, sir? Like 19.2 into
sir,
10.
it's terminating, sir.
Decimals mean where you want to use.
19.2 into 10. That's not.
Excuse me, sir.
Rational,
So it's
rational,
terminating, sir.
okay, we'll check that. Rational numbers format is of the form P by Q. P by Q should be natural numbers, not decimals. Okay.
Yes.
Okay, so let's see it is terminating or not. The denominator can be written as 64 into 3, which
Sir, I
is
don't think it is terminating.
divided by 2 power 6,
6 into
3
6.
power 1.
Yeah, I don't think,
Oh,
yeah,
yeah,
it
it's
is
not
not
terminating.
terminating.
Since the denominator's prime factorization is not of the form 2 raised to the power m into 5 power m, it is a non-terminating number.
Sir, can
Sir,
you go
I
to the
get
previous slide for once?
right.
Sure.
Or the one before this, sir. Okay, so if the denominator's end number, if it's either 0 or 5, then only it's terminating.
Not necessary. For
Sir,
example,
because like 5 into anything, it'll only come to 0 or 5.
I can have power of 5 as 0 and non-zero powers for 2. So
Oh,
simplest
so it
example
should be
is
even number or 5.
even and 5 not necessarily always imply that it is terminating, because I have number 192 here.
So the n number is even, so It's even.
It's even, but it is non-terminating.
Oh yeah.
So like that, the only technique which we should
If it's something other than 7 and 5, it is definitely not.
definitely not. Yes.
Other than what? Other than what?
The numbers which end
Even numbers and 5.
even, 5 and 0.
Yes.
That's good. Everybody clear with this?
Yes, sir.
Right.
Yes, sir.
So first part is clear. Let's see second. Methods to write non-terminating numbers. Part 2. See, let's say your number which you started, it turned out to be non-terminating.
So it's not t divided by 2 into 5. 2m
Yes.
into 5.
Yes.
n.
Yes. For example, this number turned out as 0.21212121 and like that.
Repetitive.
Yes,
This
sir.
is a non-terminating recurring number. There is a smarter way to write this number instead of writing this long expression. What is it? It is the method which is this.
Oh, yeah, I remember. We remember.
Okay.
Yes, sir.
Taught us.
So it's a good thing because I don't have to write and waste the ink, although it is a digital pen, but still 212121 again and again. I just indicate that which part is repeating. Okay.
So, if let's say like 0.1233333, after 1, 2, I can draw a line from 3.
Yeah, exactly. Another example is, let's say
Or
you have
keep two like dots.
1.343434 and so on. This will be
Line
written
on 3,
as
4.
Above 1.234, like
1,
line above.
2, 3, 4 dash.
yeah. Okay.
Sir, what if it changes at the last? Like 34343434 and ends at a different number.
So this dot which you see here is an indication to tell that there is no cheating happening. Okay.
So, but when you say that the 343434 goes on forever, how can you find the last, sir?
I'm not
Whenever.
interested in finding. I don't want
Yeah,
to
like Tarun said,
The examiner
la-
won't check.
yeah, like examiner.
So this dot, no, it is our trusted friend, and it says whenever dot goes on, the pattern is there which does not get disrupted. Okay.
What if, sir? What if?
Now to say what if you
Math is
can
not ripe
imagine-
enough for that.
to say that what if, we can imagine anything. What if the fan falls? What if the curtain opens? What if this? What if that? We can think anything, right? So that we should avoid. Okay. Now quickly tell me, what will you write this one as?
So we have to have line above
9847.
7984. You have to have one line
173.7948 and a line above.
Line above
9847.
7984.
No,
7984 from 798 and then 4798 and
Yeah,
dash.
that's what I said. I said
798.
Exactly.
Oh, like
Understood.
so what
Yes,
I
sir.
did was also right. So like I thought 173.798 and then 4798 and dash above the 4798 and
No.
Okay.
That's not.
Okay.
Sir,
Let's see. Let's
the
see.
same thing.
Let's
Wait,
see.
right, sir?
That's not right.
Let's see one thing which I want to clarify. In that example, is it
Uh,
okay to write it like this? What do you think?
It's still the same, but more work.
Yes.
So what we want, the least effort and
Oh.
complete information. Okay.
Yes.
Both of these numbers are same, but see the effort in this and see the effort in this.
Yes, sir.
So we want the least efforts, but complete information.
Yes.
Everybody clear?
Yes, sir.
Yes, sir.
Very good. Okay. Now, as you know, a non-terminate, the last thing which I want to mention in this second part, non-terminating number are of two types. You remember what are they?
Recurring and non-recurring.
Yes. This part 2 is for recurring numbers only
Yes.
and
Yes, sir.
not for non-recurring.
What did you say? I didn't-
So you just have to place dots after that.
So this method which you see by putting the bars is only for recurring numbers. It does not have anything to do with non-recurring numbers. Okay.
Yes, sir.
Any questions in this?
No, sir.
No, sir.
No, sir.
Very good. Okay. Let's see the last part, which is the most interesting for today. Extraction of rational number from its representation. With the representation, I mean for recurring numbers as of now.
Like
Okay.
how to convert 3.333 to 10 by 3.
Right. So, for example, you see the number 0.212121. Which rational number does it correspond to? That
To
is the
what?
question.
Which rational
Like
number
what
does it
divided by what
correspond to?
is 0.21212.
Yeah.
Yes, exactly. I want to see this is what divided by what.
So round it off to the nearest one, which is equal to 25. Then do it one by 4.
Ah, but we will miss out informations of the later stage, and that will not give us the exact rational number which we are looking for. Any ideas how to get this?
No, sir. So actually, if we get 1 by 4, we stop with 0.2. We don't go for 0.2.
Yeah.
You are saying that it is
No, you
1
get
by 4.
0.25.
Yeah, we get 0.25. Sorry.
So 1 by 4, which is 0.25, is much different number than this. Yeah.
Yes.
So how to get it?
2 by 84? No, not 2 by.
It is
So there's
Uh,
a non-term. There's a
This is non-terminating.
says something by
non-terminating.
so there's
Recurring number.
non-terminate.
so something by 33.
Something, but how do you guess it is 33?
Sir, because
Google said so.
no, I don't know.
No, that's
Because-
0.03030.
Because 2 plus 1 is 3.
Now we can play this game of guessing and not
I've-
guessing, and
I've-
it will
I've
go
seen
on
that.
forever.
One sec,
I've
one
seen that in
sec.
some like YouTube videos.
Yes, I think you just have to jump the point towards the right side. Something with the
21.
point. It's something with the
Yes, sir.
point, sir.
Yeah, of course, we have to utilize this pattern of repetition,
Yes.
and we can certainly never be able to get it by just hit and try. We need a smarter method to find it. Okay. let's see what it is.
Will it do anything with
Sir, I get it, I get it.
Ah,
So
what
we
is it?
have to, like, as there's a recurring number, we have to multiply this number by the infinite decimal digits, like, let's say this one into infinite. But then the point will completely skip to the rightmost end of the decimal number.
There is no end.
And it, yeah, like infinite, we are multiplying with infinite. Like, you get it?
Infinite
Yes.
is just a notation. It's not a number.
Then we divide 21, 21, 21, like
You
21
can't
is
use
divided.
infinity. You can't use infinity. in
Yeah,
operations.
we then divide it by 7, so 21, 21, 21, 21.
You can't even use infinite in a like a sum or anything.
I'll say
Okay,
infinity
screw this
plus.
plan, screw this plan.
I'll say infinity plus 1 equals infinity plus 2. Cancel out infinity, infinity. I'll say 1 equals 2.
Okay. So let's see the smarter way to find it. Suppose I describe it as the number p by q which I want to find. Okay.
Yes.
Now I multiply it by 100.
Multiply which ones?
Multiply
0.21.
both sides.
Because the
By
recurring length is 2.
Yes, exactly.
Okay.
So it'll be
What it
100x
becomes? It becomes
212 point
21 by
21212.
21, 21,
So
20,
20. Oh,
21.21212121. Right?
yes,
Yes,
sir.
sir, like that's what I was saying. Infinite x is equal to 21, 21, 21, 21,
They
21,
can't use
21.
infinite. It's 100.
I'm not
They didn't use
I'm not
infinite.
multiplying infinity. I'm multiplying by 100 both sides. Okay. Now what I do, I subtract 2 minus, I subtract 1 from 2.
What, sir?
What? Yes, the second equation by first. So what it becomes?
So it becomes
100 is equal to
21.21. It will become 21 plus
99x
0.21.
99x
21
because
point 21. That's it, sir. It
20.
become 21.
It's
what it
20.
becomes?
So it
21.
will become 21 point.
Nothing.
Sorry.
It's 21.
Yeah.
21.
No,
That's
no.
it.
So 21. 21.
It's
That's what I
just
also said.
21.
Yeah, that's
Just
what I also said.
21.
So how, sir? Like we are
Everything
so
is getting
exact-
cancelled out.
0.2121.
21.21, can it be written as 21 plus 0.21 point like this? I'm
Yes, sir.
subtracting 0.212121. That's all.
Sir, 21 will only be there.
So that cancels. Yes or no?
Yes, sir.
Yes.
Yeah.
So now
sir.
transpose the 99 to the other side and it'll be 21 divided by 99.
So what do I get? What
Zero
was
point two
the
one two one.
number
Oh,
x?
No, sir.
21
Like
by 99.
listen, sir,
0.2121.
I have one doubt.
Yes.
In
It was
100x, like
Ah.
let's say the recurring number goes till infinite, and in 100x the point jumps two digits towards the right. So 2 digits are subtracted from infinite, so it has to become like 2 digits have to be decreased from when we do 100x minus x. Like I don't know, I have to write it somewhere and show you. I just
Right.
can't explain.
I get your point. I get your point. The answer lies in why we multiplied by 100. Okay. We multiplied, but we could have multiplied by 1,000, 10,000 also. I'll show you one more way. See.
So
First
what
of all,
about 10, sir?
first
Can
of
I do
all,
10?
no.
first of all, are you clear with this?
Yes.
Sure? Everybody?
Yes, sir.
Yes. Sir.
Let me
Yes,
show
sir.
you. Let me show you. I will not multiply by 100 this time. I will multiply by 10,000. Okay. Let's see what will happen. If I treat x as 0.21212121 and so on, 10,000x
10,000x is equal to
will be equal to what?
21212.21. 1, 2, 1, 2.
No, it's 2, 1, 2, 1. That's it.
No, there's 5 zeros in 10,000.
Four,
21.
Bro,
Sir, 21 by
4
Oh,
99.
see, there's
is
4
5
zeros.
by 33.
Sorry, I thought it was 1 lakh. Oh my god.
10,000, 4 zeros.
Sir, 21 by
sorry, sir.
99 is 7 by 33. So it is divided
Is
by
is it
33.
is it understandable by multiplying
Yes,
10,000?
sir.
Yes, sir.
Now I subtract both sides.
9,999x is equal to 2121.
then
Subtraction tells me 9,999.
So you get
X.
0.2121.
This becomes 2121. Yes or no?
Yes, sir.
yes, sir.
That means what is X?
212121 divided by 9999,
99.
Yes,
which is 0.2121.
that is
Yes.
0.2121 and all comes as
The starting
2121 divided by 9,999.
999.
Is it fine?
Yes, sir.
Now see, earlier also we found that 0.212121 was 21 by 99. And
Yes, sir.
now we found 2121 by this. Does it mean that 21 by 99 is same as 2121?
Yes, sir. When you simplify it, it's the same.
Yes. And that should be the logical question. Huh? By multiplying 100 and subtracting, I get 21 by 99.
No,
Yes,
sir,
sir.
like that's not my doubt.
Huh.
Like,
Okay.
like, can I just annotate on your screen, sir?
Yeah, tell.
So, like, this is 2, like you're saying x is equal to
Hmm.
2, 1, like 0.2121
Hmm.
dot.
Okay.
And this is at infinite. It goes till infinite.
Okay.
100x
Okay.
is equal to 21.2121
Hmm. Okay.
Yes.
dot till infinite.
Okay.
But in 100x, the point has skipped 2 times to the
Hmm.
right.
Okay.
That means
The left.
yeah, to the
the
right.
right.
No, right.
That
To the right.
means
Sorry.
so that means from infinite, there are 2 digits that have been subtracted because they have been sent to the left side of the point.
Okay. Now I will
Then
ask. Understood. Okay. Let me ask one question here. What will remain if you take 1 mug of water from the ocean?
No, a
1 mug
change will happen, but
the
it's
ocean minus that 1 mug.
Is it noticeable? Is it
no, sir.
is it anything significant?
No, there is a change, but it's not significant.
Yeah.
So with infinity, that is what happens. Infinity minus 2 doesn't change infinity. It's still in,
From the first class, you seem
because
so worried about infinity.
because this is not a number. This is not a number. It's a notation. It is not a number. If I was doing 7 minus 2, it cannot be 7. It has
Yes.
to be 5.
It's like the space. It's endless.
Because 7 is a number. Infinity is not a number. And not only subtraction. If you want to add number 3 to infinity, it still remains infinity only. Nothing more. Got your doubt cleared?
Yes, sir. Yes, sir.
Yeah. So infinity is not a number. That's the answer of all of your doubts.
Yes, sir.
Okay. All right. So all of you understand this whole thing. So you
Yes,
can
sir.
So I'll just erase it.
it
No, sir,
will
you
go-
can't because I have.
Oh, is it? Okay.
Yes, sir.
So everybody fine with this?
Yes, sir.
Yes, sir.
Now let me give you and say what is 23.472 bar. I want to see this. First of all, I know that by decimal representation, this is a non-terminating recurring number.
Yes, sir.
Yes, sir.
So you don't
Okay.
need to multiply the x with 100 or anything because it's the number is already outside this. Oh wait, yeah.
Yes.
But it is
Yes.
still written as 23.47247247247. I just used that smarter notation.
So I have to still multiply the x with some
Yeah,
number.
I want to see this as something divided by something.
Okay.
Try it.
So can I do 1000x, sir?
You are free to do.
Yes, sir.
Sir, it is 23447. Sir, it is 23472 divided by
Divided by
999.
9999. Yes, sir, I'm getting that.
No.
No, it's only
Yeah.
999.
Yeah,
Yeah, it's only
999.
999.
And
You said 4 nines there.
Yeah, you said 4.
I said-
numerator is not 23472.
Sir, yeah,
See
but
carefully. See
So
carefully.
23472.
The denominator is 990.
So it's 23472 divided by 999.
No.
Sir, yeah, sir, it's not the same, sir. It's giving me 23.495495499.
Let's see what happened.
So wait, sir, I
Suppose
used 10,000.
y is 23.472472 472 and so on. I multiplied it by 1000. I will get 23.
23472.
47.
So when I do
0.474772.
10,000, I'm getting 47443. 4733.
Oh, I have to
474,
subtract
347.
23 from it.
Yeah, right.
Oh yeah.
Oh, yeah, okay.
Sir,
That's
it's
fine.
2339.
Sir, but when we subtract y, we have to Okay, I get it.
So it's still
Is
the
it-
same.
I'm sorry.
So the answer is 23438.
4,
Sorry, 9.
what?
23449.
What?
Yeah.
23449.
Yeah.
Yes,
so
sir,
it's-
it's 23449 by 999.
Oh yeah.
So your rational number is
23449.
divided by 999.
999.
Understood?
So we can simplify it.
No need. I don't
Sir,
want
but
a simplified
Yes, sir, I'm
number.
getting 23472.
When Nitish asked if we can do it with 100y or 1000y, you said you're free to do with 100y. Then
Yeah,
how is it possible with 100y, sir?
This
So-
is not.
This is not possible with 100y.
I said you are free to do. I did not say that you will find the correct answer if you do. There is a difference. You are free to do, but you will not reach the right answer.
Okay, sir.
The plan, is I'll tell you the simplest thing. The plan is you multiply by anything. Doesn't matter what you multiply with. I just want to see the decimal digits same. Okay. You
Yes,
multiply
sir.
by anything. But just that I want to see decimal digits in both the expressions. They should be same. So
Sir,
that
it's actually
when
not
So
I
like
recurring.
the 472 cannot be separated. If it's in the other side, it should be 472, or if it's in the left, or if it's in the left side, it should be a whole. Or if it's in the right side, it should be as a whole. The 472 pair.
Sir, this number is actually terminating, sir.
this is a non-terminating number.
So I just checked it in the calculator.
Very good.
It ends with 5.
Correct. It ends because the calculator is not sufficient enough to
So
I
for
find
me,
know
it's
the
not
decimal
ending, sir.
expansion.
it actually has a bug. Like any calculator, there'll be
Every calculator
For me, it has no
utilize
end.
F. It will be for you also, because for you this it's at least finite numbers only which can come in the screen. Correct, no?
So the calculator has approximated 472 to 5.
It is not that.
So when you calculate it by calculator, 23449 divided by 999, your normal calculators will give you 23 point certain finitely many digits. Yes or no?
Yes, sir.
Yes. Now, if you go to an advanced calculator, it will tell you 23 point more digits. If you go further, it will give you more digits. And likewise, it is the quality of calculator which is utilizing the decimal expansions. The highest calculator if you have, it will give you all the expressions, which is in your hand, the pen. You wrote it to 23.472 and the bar.
So will it show in the calculator 23.472 bar? Like is that
No,
calculated like that?
So,
No.
but this is possible only for recurring non-terminating numbers. But how is
Yes.
it possible for non-recurring, non-terminating?
yeah, because it's not this method doesn't work for them. It works only for a recurring non-terminating, because we utilized somewhere or the other this pattern of repetition. That's why we chose to multiply by 10,000 or 1,000 or whatever. Since in the non-recurring numbers, there is no pattern, there will still be some things, not exactly this thing, but there will still be some things which we could do there.
So there's a calculation even for non-terminating, non-recurring.
Yeah, there is. There is. For example, for the sake of future, we will be able to know what is 1.4142851347912. There is no pattern. You cannot identify any pattern. I did not write intentionally all the digits, but there is no pattern. Now it's not a recurring number.
Yes,
Still,
sir.
we will be able to know that this is what number. Of course, it will not be rational number. It will be an irrational number, but their methods are different. Okay.
Yes, sir.
Any questions still here?
No, sir.
no, sir.
No, sir.
Okay. Let me give you a more broader view. Okay.
Not recurring, sir.
a combination of full real numbers, number line.
Yes.
See, if this is your number line, this number line is composed of three type of numbers. One is terminating. Another is non-terminating recurring. Another is non-terminating non-recurring. The yellow line, the number line, has only three type of numbers: terminating, non-terminating recurring, non-terminating non-recurring.
Mm.
Let's say I want to color these numbers. Okay, I want to color that. I want to give the red color to terminating. I want to give the green color to non-terminating recurring, and I want to give blue color to non-terminating non-recurring. Now, if you imagine, the whole number line will be composed of red, green, and blue dots.
Yes.
Yes.
Yes, sir.
So irrational numbers don't come on this line.
So it will look like something this form.
So it will look like the pixels on the TV.
So why is the red dots terminating line, sir?
Can you see how these three colors are forming a line?
Yes, sir.
So the so-called yellow color line, it now becomes a mixture of three colors: red, green, and
Yes.
blue. Now I want to ask one question. Who are more? Is terminating number more?
No, sir.
Is non-terminating recurring number more?
So
So
non-terminating.
probably non-terminating recurring and
Sir,
non-terminating non-recurring are the
all
same.
three are equal.
Yes, sir. All three are
All three are
equal
equal.
because
No,
everything go till
terminating-
infinite.
So terminating ends, right,
Ah.
sir?
Yes, sir.
So but terminating ends, right, sir?
Yeah, but
No.
no, how?
The line goes till infinite.
Yeah, the line goes till infinite. Everything is infinite.
Yeah, you can't really
Everything's
find
equal.
out.
So who
Oh,
is
you're
more
asking how
populated?
many numbers there are, sir?
Yes.
I
If
thought
I
you were asking
start,
how many decimal points there were.
no. So here again, carefully, I want to count how many terminating numbers are there. I want to count how many non-terminating recurring
So
numbers.
it's not possible, sir.
Everything
And
is infinite,
yes,
sir.
everything is infinite. But
Both
still,
three.
Sir, can't we just take a specific space and find out which is more densely populated?
yeah,
So
let's do that.
actually, terminating is the most.
So everybody understood the question, no? Firstly,
Yes, sir.
sir.
Yes, sir.
The number
Okay.
line, which is more?
Who are more in number?
So terminating, sir.
Terminate.
I
All of you
think they're
think
equal. Infinity.
Me too.
It's equal. Equal.
Terminating, sir.
to your surprise, terminating numbers are least.
I told you.
Oh.
I told in the first sentence.
Sir, how, sir? Like,
They go till infinite. The number line.
yeah, it will go till infinite, right? So, like, let's say,
You can
the
take a
terminating-
specific.
the
Sankar, you can take a
terminating
specific space and then calculate
So
like
from
which
2
is
by
more,
3
which is
to
less.
2 by 5. Terminating will
Yeah.
be the most. I mean least.
Least,
no, sir,
least.
but I'll say, let's take a terminating number, which is non-terminating. It's not reaching the limit of infinite, but it's not uncountable.
A terminating number that's non-terminating.
No, like a terminating number, which is not reaching infinite, but it's not countable.
Terminating by definition, it does not
It has an end.
reach. It has an end.
Yes, sir, the the decimals, it has an end, but it's not countable and it does not reach infinite.
So firstly,
So
understand.
5,367,000. Like
Firstly,
that.
understand what I want to ask. Okay. I'm not asking the digits after the decimals. I'm not asking that. I'm asking on the number line. I color terminating numbers as red color.
How many terminating numbers are there? Like whole
I color
numbers?
non-terminating recurring numbers as green, non-terminating, non-recurring as blue. So the number line will be like a holy line, red, green, and blue. Which color do you see the most? Do you see red color the most? Do you see green color the most? Or do you see the blue color the most?
Probably blue.
I think it's blue the most. No.
Yeah, me too.
Yes.
Getting
So
the
I
point?
still don't get it, sir, because you said infinite is not a number, it's just like
A notation.
Notation.
yeah, it's a notation.
Let's say, just like you say 0.212121. This is a non-terminating recurring number, right?
Green.
So on the number line, it will look like a green color somewhere.
A dot.
Yes.
A dot. Okay. Getting it?
Yes, sir.
So I don't worry about what are these things. I just worry about the location of. Okay.
Yes,
So
sir.
this was just an excursion. If you are interested in knowing, you can look for this person.
What is that? George Cantor.
Yes.
YouTuber.
No, website.
So that is the person. This is just a excursion into the subject. Okay. So see you in the next class.
Yes.
Thank you,
All
sir.
the best.
Thank you, sir.
All the
Bye,
best.
sir.
Bye, sir.
Thank
Bye.
you, sir.
Thank you,
Bye,
sir.
sir.
So will we get any assignments from
Yeah.
Maths, sir?
Yes. You will
Like
get,
this Saturday?
you'll get it.
I won't be attending the class from tomorrow to next week, sir.
So that you can tell to the person
Yes,
whom
sir.
you
We
should
informed.
report.
We informed. Thank you, sir.
Thank you, sir.
Bye.
Bye, sir.
All right. Good night.